good noon dear friends, myself Sonigra, and today we are going to discuss the topic of multi-views representation in the subject of mechanical drafting, some of the basic concepts and the solution of some typical problems related to the multi-views representation. The highlights of today's representation is: the first we will discuss the basic concept, then solution of typical problems, then selection of views to represent an object, how to select with the view, and orthographic writing steps. So these are the four outlines of the today's presentation, in which we will cover how to solve typical problem, how to select the view to represent an object, and what are the orthographic writing steps. What is multi-views representation? Multi-view projection is an orthographic projection for which the object is behind the plane of projection and is oriented so only two of its dimensions are shown. Generally, three views of an object are drawn and the features and dimensions in each view accurately represent those of the object. So that is multi-view representation. What is multi-view representation? It is represented by the one view is front view. It shows the width and height of the height dimensions of an object. Second is top view. It shows the width and depth dimensions of an object. Then side view, or it is also known as profile view. It shows height and depth dimensions. Normally right hand side view is used in the drawings as it is the standard view. Similarly, front view correlates with the rear view. It also shows width and height. With respect to top view, there is a bottom view, and with respect to side view, two side views are there. One is right hand side view and another is left hand side view. So there are six views in multi-views representation: top view, bottom view, front view, rear view, and two side views. But how many views should be drawn to represent an object? That depends upon the size and shape of the object. In some cases, only one view is enough to represent the full object. In some cases, two views are needed. In some cases, three views are needed. And when the object is completely asymmetrical, it is not symmetrical on any size, on any direction, more views are needed to be represented in the drawing to show the object on drawing sheet. In detail, we will discuss how many views should be selected and which view should be selected to represent an object. Why multi-views representation? What's the importance and why it is used in drawing practice? The advantage of multi-view drawings over pictorial drawings is that multi-view drawings shows the true size and shape of the various features of an object, whereas pictorial views distort true dimensions, which are critical in manufacturing and construction. Because whenever we take photograph of any object, the object which is nearer to us or nearer to the camera lens, its size appears longer, and the object which is away from the camera or away from the viewing side, its dimension will appear little bit smaller. So to overcome this problem, we use multi-view representation or orthographic projection of an object. This is the pictorial representation given over here. Draw front views and side view of this object by first angle projection method. Here the object is given, and to draw its front, this is the direction to show for front view, this is for side view. So for that, first of all, draw XY line and draw its side view, its front view. If you look from front side, from here, if you look from here, this object will appear as shown over here. This width is 50 mm, that is distance from this end to this end. This height is 15 mm, which is represented over here, and this height is not mentioned in this drawing, and this length is 30 mm. So distance from this point to this point is known to us, that is 30 mm. And this is a taper face. this taper face. So in front view, this taper face can be represented by just an inclined line as drawn over here, and this inner edge, this corner and this corner, which are hidden behind this plane, so it is not visible if we look from the front side. Hence both these corners are represented by this dotted line and this dotted line. So these two dotted lines represents these corners. Similarly, this is the front view. Similarly, if we look from the left side or left hand side view, would appear as shown over here. This dimension is 10 mm, which is this one. This dimension is 20 mm, which is this one, and this one also 20 mm. This height, which is given in the drawing, that is 15 mm. You can think of this dimension. This is 30 mm. So that is this width, in which here cut portion is there. So from distance from this point to this point is given as 30 mm, which is represented over here. So these are the two views of this object, front view and left hand side view. It is called as the orthographic projections. Now regarding selection of views, how to select view for any object, which view is enough to represent the object, that we will discuss in detail. Select an adjacent view. Choose the view that have the fewest number of hidden lines. This is the first rule. For example, here object is given as shown over here, right? Now if we draw its front view, direction from here is this one, it would appear as shown over here. This is its front view. And if you look from another side, these two are the side views. One side view is here, another side view is here. Only one difference between these two side view is this dotted line. You can see here, this red colored dotted line. Here it is a dotted line and here it is a full line. Because if you look from the right side, this corner will appear to us, hence it is represented by full line, and this is hidden, so it is represented by dotted line. Rest or parameters are similar in both these cases. So which view should we select? Yes, read here. Choose the view that have the fewest number of hidden lines. So in both these two cases, in these two side views, here dotted line is there, so it is not advisable to use this drawing. We should not draw this side view, and this side view should be drawn to represent this object, because this side view is having less number of dotted lines as compared to another side view. So this is inappropriate representation, and this is a good representation of side view. Similarly, other two views, top view and bottom view. Now tell me which view should we select, this upper one or lower one? Think of it. For that, think about the number of dotted lines in both the cases. You can see here number of dotted lines are there. This is the dotted line, which is full line over here. So of course we should not use this view, and this view should be selected. So this is a good practice to draw this view, and this is not appropriate representation of an object. So this is also to be removed like this. So for this object, these are the three views which are selected to represent this object. Now another case, select an adjacent view. The second rule to select the adjacent view is choose the minimum number of views that can represent the major features of object. We should not draw all 6 views for any object if not required. So we should select as minimum number of views as possible in the cases. For example, in this case, if you look from here, this would be its front view, this is the side view of this object, and this is the top view of this object. Now think about this edge, this L shape edge, it is this one. So this L shape is there, so this side view is necessary, because without drawing this side view, it would be difficult to imagine about the shape of this object. So this is one of the views which is compulsory to be drawn to represent this object. Now second, this one. Think about this dimension. Here holes allocation or holes location can be specified on the same view, here and here, so that it would be easier to understand. The location of hole is here, so on the same view it could be represented. This is the distance. For example, this we should show this distance instead of this distance, right? And these are the dimensions which are difficult to interpret, like this dimension and this dimension. So for that, it's advisable to use or to represent this dimension in its appropriate view. So here it is difficult to represent, right? So this is necessary view. You can think about this. This would be the necessary view. Yes. Now next object. Select an adjacent view. Choose the views that are suitable to a drawing space. Yes, that is the third very important rule. We should not select the views such that we have to use more drawing space and very big drawing space goes to wastage or it remains blanks. For example, this is an object. So for this object, these are the two views, front view and top view, right? If you look from the front, this cylinder will appear as two circles as represented over here, and if you look from the top, this would be its view. Now think about the views of this object. Yes, not enough space for dimensioning, right? Here dimensioning space is not there, here also space is left. See here, this is the drawing sheet, light blue colored. This is a drawing sheet, and in drawing sheet, whenever you draw two views, you should take care about this space. It should not touch this line. Here some space should be left to insert the dimensions of this object. So here not enough space for dimensioning. We should provide here proper space to insert the dimensions. It's a poor drawing, you can say, because here space is not put. This could be the good practice to represent this object. This is also the same object. Two views are selected, side view and front view. Top view is not selected in this case, but even with this side view and front view, we would be able to identify all its features. Hence, it is advisable to draw these two views instead of top view and front view. So I hope with this example, it would be clear to you how to select appropriate view. So this is a good practice to draw two views. Now one example for view selection. How to select a view. This is one of the very much important example, and it will clear your concept about the selection of views. This is the front view of this object, right? It is given over here. Now draw its front view. If we look from the front, this object will appear as a rectangle drawn over here. So this is the front view, and height and width are known to us. The width of this object is this one, height of this object is this one, which is represented over here, width and height. Now this is depth of this object, which would be visible either in top view as a height. This is D, this one, it is drawn over here. Then draw reference line. So this view is the top view. Now think about size description and shape description. Let me draw these two views, front view and top view. Size and shape are visible in these two views. First tell me, size is visible, yes or no? Yes, size is visible in this case. But what's about shape? Shape is not visible in this case, as this triangular shape is there, which is not visible in this two view, right? Size is visible, shape is not visible. Now next, mislead to this. If we draw these two views only, we can imagine that the object may be like this or it may be like this. So the shape is misleading in this case. so which is not there in this case, so we should not use that. Now think about another two views. Say this is front view or three views. This is third view of this object, right? Side view. It is drawn over here. If we represent its side view, then size description is clear, as well as the shape description is also clear in this case. So here it is advisable to draw the third view as well, because with these three views we would be able to identify its size and shape completely. Now for front view and right hand side view, what's the case? For front view and right hand side view also, this would be both size and shape would be visible to us. Now one view drawing. Now think about the case. Have you seen any object in which only one view is enough to represent all parts? Yes, here is the case. A flat part having uniform thickness. In those objects or in those drawings, only one view is enough to represent the full object. The example is shown over here. This is an example in which you can draw only one view, right? Like this. This is only one view of this object, and thickness of this object is uniform throughout this plane. So in such kind of problems, only one view is enough. So this is here. This top view is to be selected to represent this object, and we can mention that it is having uniform thickness of so and so millimeter. This is the side view of this object, and this is the top view of this object. These two views provides this to side view and top view provides only information about the thickness of this part. So only for thickness, no need to draw both these views. So it's unnecessary view. You can trim this view. So trim these two views and write its thickness like this. It's a so and so millimeter thick. Then it's okay. Only one view is enough to represent this object.